Okay, guys. Oops. Guess it'd help if I put the camera in the correct place, huh? All right. I'm going to talk through problem 20, which I actually already solved. I already wrote it out. So, problem number 20. We are told we have a baseball. It's launched with a horizontal speed of it rolls 1.25 meters per second off a bench that is 1 meter from the ground. And we're asked to find the change in time. So, I'm going to do one thing here first. I'm going to show what the velocity diagram should look like. Now, I'm looking for change in time, and so I'm going to look to see how long it's going to fall vertically, because I just want to know how long it's going to follow a trajectory like this, right? So I'm going to basically look to see how long it's in the air during this 1 meter of vertical motion. So looking at vertical velocity, my vertical velocity starts at 0 and it will end at some non-zero negative value because of course it's pointed down. I know the vertical acceleration. I don't know the delta t, and I don't know the finished velocity. That's what I'm looking for, the delta t, that is. But what do I know? Well, if I come back to chapter 2 equations again, which I think they actually rewrote, yep, they actually rewrote here on the chapter 3, so we should start using this one. These are the same equations we were using on the previous page. So if I look at this one, this is the equation that I want to use, right? I know basically displacement. My initial velocity is 0, and I can use this to solve for time. So I'm going to use that equation, which I wrote here. I put it in terms of x. Should have been y. Let me just correct my letters there. It should say delta y equals a y, delta t squared. Okay. Now the initial velocity is 0 because when it first rolls off the bench it has no vertical velocity. So that term goes to 0. Rearrange and solve. That should be y again. Rearrange and solve for t, or delta t, and basically this is what I have. It's ay. That's a subscript. It looks like a times y. Sloppy. Let me make that a little y. A subscript y. Substitute in your values and you should get this. Be careful to track out the correct number of significant digits. How many significant digits would we use? Well, the initial problem, we're given 3 significant digits. And yeah, we know acceleration due to gravity is 2, but again, this is considered unlimited precision. So what would govern would be the 1.25 from the initial problem here. So, and because this is, well, anyway, so I would report it out to 3 decimal places. All right, so now part B, they ask you how far from a part on the floor will the ball hit. So now they're asking us to find how far it travels this way. So label that delta x. So how far does it travel in the horizontal direction? Again, that'll be really easy. So we're going to come back to this equation. It's the same equation I used on the last part A, except for it was, in this case, the displacement we were putting in was y, vertical displacements, instead of horizontal, but it's the same equation. So this time I do have a velocity because we're looking at everything in the horizontal component. So I have a velocity. The initial and the final velocity are all going to be identical, but I have no acceleration in the horizontal direction, so that whole term goes to 0, which basically takes me back to the very simple definition of velocity, which is basically velocity equals change in x over change in time, right? That's the equation for uniform motion. So substitute in your values. I am not putting units in here. Shame on me. Don't follow my example. Put your units. Carry it out to 3 decimal places, and that should be your answer in seconds.